In this video clip, we're going to use the given graph of the function y equals f of x to sketch the graph of the modified function. So we have two modified functions. The first one is f1 of x being now f of x plus 3. So the graph we're trying to make is y equals f of x plus 3. So what kind of transformation does using x plus 3 instead of x produce? So this plus 3 added directly to x is responsible for moving the graph left by 3 units. So to sketch the graph of this modified function, we just need to take this original curve and move it left by 3 units. So when we're done doing that, we're going to end up with this red curve. That's the graph of y equals f of x plus 3. And looking on the second function, this is f2 of x being equal to f of x minus 2. So trying to graph y equals f of x minus 2. And this minus 2 subtracted or attached directly to x is responsible for moving the graph right by 2 units. So we need to take the original curve for y equals f of x and move it right by 2 to get the graph of this modified function. And when we do so, we end up with this red curve. That's the graph of y equals f of x minus 2. We're going to be using the given graph of function f of x to sketch the graphs of the following 3 modified functions. So we start with the graph of y equals f of x plus 5. So that's a modified function. This plus 5 at the end of the function is responsible for moving the graph up by 5 units. So to get the graph of this function f3, we just need to take the original curve and move it up by 3 units. So if we do so, we end up with the graph y equals f of x plus 5, this red graph. And if you look on this function f4, this is f of x plus 3 plus 5. So there are 2 modifications being done. So plus 5 is responsible for moving the graph up by 5 units. And this plus 3 attached directly to x is responsible for moving the graph left by 3 units. So we need to take the original black curve, move it up by 5, and then move it left by 3. When we're done, we end up with this green curve. So it's the original curve moved up 5 units and left 3 units. That's the graph of y equals f of x plus 3 plus 5. And for the third function, we're trying to graph y equals f of x minus 2 minus 3. So this minus 3 in the end is responsible for moving the graph down by 3 units. And minus 2 inside of the function, so this minus 2 is attached directly to x, is responsible for moving the graph right by 2 units. So we just take original curve, move it down by 3, move it right by 2, and we're going to get the graph of the new function. That's our new curve, new red curve, moved down by 3 and right by 2. That's y equals f of x minus 2 minus 3 graphed for us. We're going to work on making the graphs of the following 2 functions, modified functions, using the graph of original function y equals f of x. So for the first one, we have f6 of x being equal to negative of f of x. So trying to graph y equals negative f of x, and this negative in front of the function is responsible for the reflection with respect to horizontal x-axis. So we just need to take the original curve and reflect it with respect to x-axis. So everything that was below is going to be above, and everything that was above is going to be below. So once you're done with the reflection, this is the graph of y equals negative f of x. For our second function, we're trying to graph y equals f of negative x. This time negative is applied directly to x, and that is responsible for reflection with respect to y-axis. So we're going to have to take original curve and reflect it with respect to y-axis. So everything that was to the right is going to be shifted or reflected to the left, and everything that was to the left is going to be reflected to the right. When we're done with that, we end up with this curve. This red curve is the graph of y equals f of negative x. We're going to work on making the graphs of the two modified functions given the graph of original function. So for the first modification, we're trying to graph y equals 2 times f of x. And this 2 is being multiplied by the entire function f of x, so that results in the vertical stretch of the graph by a factor of 2. So what physically happens to the graph, every y-quadrant is going to get multiplied by 2. So this point had y-quadrant 5, so the new y-quadrant of that should be 10. And likewise, this y-quadrant was negative 4. When you multiply it by 2, it should be negative 8. So when we're done with this multiplication of y-quadrants by 2, we end up with this red curve. And that's the graph of 2 times f of x. So for this next function, we're trying to graph y equals 1/2 times f of x. And this 1/2 in front of the function is responsible for the multiplication of every y-quadrant by 1/2, so that essentially shrinks the graph in vertical direction by a factor of 2. So this is our graph, so we're going to take every y-quadrant and multiply it by 1/2. So this point was at y-quadrant 5, so if you half it, it's going to be exactly 2.5. And the similar thing is going to happen with this point. It was at the height negative 4. Take half of that, it's going to be the height of negative 2. So when we're done with all of those shrinkage operations, we're going to be looking at this red curve. That's the graph of 1/2 times f of x. We're going to use the given graph of original function y equals f of x to make the graphs of the following two modified functions. So the first modified function is y equals f of 1/3 x, and this 1/3 multiplied directly by x is responsible for the horizontal stretch of the graph by a factor of 3. So the x direction is always working in the opposite way of the y direction. So you take the graph of original function and you're going to multiply the x-coordinate of every point by 3. So the x-coordinate of this right-hand point is 5, so multiplied by 3 you're going to get 15, so it's going to be off the charts. This point had x-coordinate positive 2, so if you multiply it by 3 it should be at x-coordinate equals 6. So when we're done with this horizontal stretch, we end up with a curve that looks like that. Okay, so that's the red graph for the y equals f of 1/3 x. And for the second function, we're trying to graph y equals f of 2x. And this 2 in front of x is responsible for the shrinkage of the graph in horizontal direction by a factor of 2. So every x-coordinate is going to be divided by 2 essentially. So this point has x-coordinate 2, so it's going to get x-coordinate 1. This point has x-coordinate 5, so it's going to become a point with x-coordinate 2.5. So when we're done with all of those things, you end up with a graph that looks like this red curve. So that's the graph of y equals f of 2x.